Hey there! In this video, we'll start learning about Pandas DataFrame. DataFrame is a two-dimensional data structure which contains three main components: the index, the column labels, and the values, which is the underlying data. And what is important to know, each column can contain a different data type, and that's awesome because it means that DataFrame is a very powerful data structure. But wait, let's not forget about Pandas series. Pandas series and DataFrame will always be present in your data analysis. Let me tell you what I believe to be a good approach for learning Pandas properly. The file icon represents our data frame, and on this data frame, we'll type a valid Pandas command, and it will either return another data frame or a Pandas series. And the takeaway here is always ask yourself what the command you are about to type will return. If it returns a Pandas series, you will be able to use everything we learned in the last two videos. And in case it returns a Pandas data frame, you will use everything we learned from this point on. I find this exercise very efficient and I hope it makes sense to you. Okay, let's get started. The first thing you have to do is to import the libraries we're gonna use, in this case Pandas and NumPy. We already know that Pandas DataFrame is a two-dimensional data structure very similar to a table, and each column is a Pandas series. And what else do we know? We know that each column can contain a different data type and that Pandas is built on top of NumPy arrays. Now the question is, how can I create a data frame? Well, there are actually two ways to do it. The first way is a very well-known way, and that's using the Pandas IO API. That's a very fancy name, but what that actually means is that Pandas has a lot of functions which are able to pipe data to Pandas or create data frame directly. For instance, we can read CSV files, we can read HTML files, Microsoft Excel files, and more. And what is nice about it is that it is not only able to read, but also to write data to those formats. This is one way, and I think that's going to be one of the most common ways you're going to be using that. But I also want to show you how to do it manually. Why? Because especially when you start learning Pandas, might be that you get some files which are not that easy to parse, and these functions by their own will not be able to create a data frame. Then learning how to do it manually is very, very important. Okay, let me show you one example of how to do it using the IO API. We import Pandas as PD, then you type PD dot. If you start typing read and press tab, you're gonna see all the formats it can read. It can read CSV file, Excel file, HTML, and so on. I have one example here already done for you. I download one dataset from this website, and by the way, this is a very nice source of dataset for you. So let me just show it to you. And that's from the University of California. This is the automobile dataset, but if you press the icon of the university, you're gonna see all the datasets that you can use, and you can download it for free. Alright, let's come back to our notebook. What we do, I just called PD, read CSV, which is the function which reads CSV file. Then I provide as argument the path of my file. If I execute the cell, ta-da, we get our data frame. Nice. And as I said, the data frame is composed by the index, here on the left side, the column labels, and the values. That's one way to do it, but let's go through how to do it manually. When you want to do it manually, we're gonna be using a method called dataFrame. And let me just give him some space here. And how to do it, you just type PD, then dataFrame, and if you inspect this method, you're gonna see that it has three main parameters: the data, the index, and the columns. And the data is important. Why? That's basically what we're going to provide to this method to create the data frame. We can provide different data types, but to be honest, only two are important to know. The first one is creating data frame from a dictionary, and I listed here as important to know, and the second one from a NumPy array, which I wrote here, good to know. Let me show you how to create a data frame using a dictionary. In this case, the values of this dictionary is going to be list. If you have no idea what is a Python dictionary, I have an entire video about it, and please check it. Okay, the keys of the dictionary will become the column labels, and the values of the dictionary will become the data of our data frame. We already have our dictionary called data, then let's provide that to the data frame method. Then we type data. If I execute that, Nice, I don't see it because I didn't print it. Then, now, we see it. As I mentioned, the key will become the column labels, so car name, doors, field type, and price. And the values will be the values of this data frame. This is very, very important to know. And now, let me also show you quickly how to create Pandas data frame from a NumPy array. Yep. And here what we have, we are creating a variable called data, and we assign to that a NumPy array with 36 elements. Let me just comment the reshape method, and I'm gonna do that step by step. That's gonna be easier to understand. If I just print this NumPy array, look, we get from 0 to 35, because the number you provide to a range is always excluded. Now, I'm gonna convert this NumPy array in a two-dimensional NumPy array, and for that, we use the reshape method. We can then provide this two-dimensional NumPy array to the DataFrame method. Now let me just uncomment those guys here, and voila. But look, the index and the label now starts from 0 and goes to 5, right? Because it is actually a NumPy indexing. By default, index in Python starts with 0. And if you want to provide a column label to our data frame, we can use the column parameter. Let me just inspect again this method, and then you see here that we can provide columns and index, and by default they are none, right? So I take columns. Now we see that we are creating a Pandas data frame from a NumPy array, and we are also providing the column labels A, B, C, D, E. Then that's it about how to create Pandas data frame. And my goal in this tutorial is that you get used to Pandas data frame. It doesn't matter to me if you read that from external source or if you create that manually. But creating Pandas data frame manually from a dictionary again and again is very, very important. Alright, let's start talking about basic operations on data frame. I'm gonna be using the I/O API using the read CSV function, and what I did, I took that file I showed before, the dataset, and I modified a bit. Let me show you what we get. We get our data frame. And how many rows do we have? Well, 205 rows and 6 columns. And we are not seeing 205 rows, right? We can make pandas showing us all the rows, but at this point, it is not important. But what I want to show you is, as soon as you create our data frame, how can we view our data? The first method I want to show you is the head method. When you call the head method, it will return by default the first 5 rows of your data frame. And if you want to show less or more, you just provide the argument as a number. For instance, let's show 6 or let's show 10. Cool. I will set it to 3 just to get more space on the screen. In case you want to show the last rows of your data frame, you're going to be using the tail method. By default, it shows the last 5 rows. But it doesn't stop you to type the amount of rows you want to see. If I want to see the last 3, well, I just type 3. We can also get a random number of rows of a data frame. And for that, you type or you call the sample method. And again, you provide the number of rows you want to get. But now, I have a question for you, which is, do I modify my data frame when using the head, tail, or sample methods? The answer is no. Every time you use the head, tail, or sample methods, you are creating a new data frame. You are not modifying your original data frame, alright? Okay. We talked about the main components of a data frame being the index, the column labels, and the values. Let me just show the first 3 elements of this data frame. And to get the index is exactly the same what we did with Pandas series. We just call the index attribute. And in case you want to get this index as a list, what we can do, we can use the Python list function. And there you go, we have the index as a list. There's actually another way, but it's a bit more complex, but I'm going to show you. This object has also a method called toList. If I run it, again, you can get a list. Alright, we know how to get the index, but now how can I get the column labels? Well, you only call your data frame and then you type columns. And what we get? Well, the column labels. Actually, we are not only getting the column labels, but an index object. And again, if I want to convert that to a list, we can use the toList method. Cool, there you go. Car name, field type, up to price in euro. Okay. Now, let me tell you how to retrieve the data of a data frame. Now to get the values, you type the name of your data frame, the dot notation, then values, and that's an attribute. Now I want to stop and think a bit in what you see in your screen. What is that? This is an array. And we saw that before. I showed you that you can create a data frame from NumPy arrays, correct? Let me just come back there. This is the NumPy array we used to create this data frame. And what we just saw was the opposite. We had the data frame, and now we are getting the NumPy array which was used to create this data frame. And that's why it is good to remember that Pandas is built on top of NumPy arrays. As I want to give you the complete information, there is also a method for that, which is toNumPy. And if I run it, I get exactly the same thing. What else do we need to know? Well, we need to know how to inspect our data frame. And if you don't mind, let me print the data frame again. And let's say we don't know how many rows and columns this data frame has. And for that, we can use the shape attribute, and it will return a tuple where the first element is the number of rows and the second element is the number of columns. And by the way, if you also watch my videos on NumPy arrays, you also know that shape is a NumPy attribute. Now, how to get the data type of each column of a data frame? Well, for that, use the dtypes attribute. And what we get is a Pandas series where all the column labels becomes the index of this series. And we see that car name is of type object, field type also, doors and car body. And car length and price are of type float. And what is object? Well, object is nothing but a string for Pandas series. Okay, shape and dtypes are quite useful, but there is a better method to use and you're gonna get everything at once. And this method is called info. It says this data frame has 205 entries or 205 rows and 6 columns. And then it also tells us for each column what is the data type, and again we have the same result here, but on top of that it also tells us if there is a missing data. And how can we see that? Check this column here. It says non-null count. So how many non-null count are there? If you have any number here which is lower than the one you find here, 205, then you know that there is a missing data. What else we can get to know about our data frame? Well, there is also a very nice method that we can use to find basic statistics of our data frame. Again, I'm going to show our data frame. And now I will present you to the describe method. When using the describe method, by default, you're going to only have information about your numerical data. It means that car name, field type, doors, and car body, they will not be included in this analysis. If you want to include everything, categorical and numerical data, we can inspect this method. And we see that there is a parameter called include, and by default is none. And if I set it to all, I want to show all, then voila, we get information about the entire data set. Okay, how to read it? Well, now you have on the left side our index, and we have count, unique, top, frequency, mean, standard deviation, minimum, maximum, and all the percentiles. As you can imagine, for categorical data, the information about mean, maximum, and percentiles does not make sense. This is why it returns NaN, which stands for not a number. And on the other hand, unique, top, and frequency, they do not make any sense for numerical data, and therefore it also returns not a number. Okay, what else we can get from this result? Well, we can also get that there is no missing data. How do I know that? We see that all the columns have 205 elements, which is the number of rows we have in our data frame. Perfect, no missing data. But look to the car name column or car name series. There are 205 elements, but only 147 are uniques, and Toyota Corona appears 6 times. What we can do? We can access this column, the car name, and check if this Toyota Corona is a duplicated data or not. But for that, we should learn how to access columns or how to access a Pandas series out of a data frame. There are basically 2 ways to do it. One way is using the bracket notation, and the second way is using the dot notation. Let me show the data frame, and let's say we want to retrieve the car name column. What to do? Using the bracket notation, you just call your data frame, then brackets. Now, what you need to provide is a string with the name of the column, in this case car name. What I get is a Pandas series. Remember, each column is nothing but a Pandas series. If you want to get another one, well, you just change the name. So car name, now I want to get the doors. Well, I get now the Pandas series, which represents this column, doors. So let's compare the very same thing, and I will only show had only 3 elements. Okay, now how to use the dot notation? Well, as it is the dot notation, you press dot, then you just type the name of the column, in this case car name. And if I run it, we get the same Pandas series. And just to have the same result, I can also use head 3. Now they are exactly the same. Alright, now that you know we can access a column using either a bracket or dot notation, I'm gonna tell you my personal preference. I really don't like the dot notation. Why? Let's say we want to access the last column, this one, price. If I use the bracket notation, everything is fine. But now, if I use the dot notation, just Ctrl V, now it raises an error. Why? Because now my column label has a space, and every time you have a space, you cannot use the dot notation. This is one of the drawbacks. And the second one is I really like to use the dot notation to call methods. For instance here, dot head, dot tail, dot sample, dot count. But as I said, this is only my preference. You can do whatever you want. I will just come back to car name here. And there we go. It doesn't work. Yep, now it works. And just to let you know, from this point on, I will be using the bracket notation. And now that you know how to access a column out of a data frame, well, let's learn how to create and delete columns. How to create a new column. We type the name of our data frame, in this case mine is data frame cars. Using the bracket notation, again, this is another reason why the bracket notation will help you, and we type whatever string you want. Let's say I will type new, right? And I will say new equals to 5. What does that mean? I think it's gonna be easier if I show you the data frame. And now what I'm gonna try to do is I'm gonna create a new column called new, and I'm going to assign 5 to each row, and this is actually the idea of broadcasting of NumPy array. Let me just run it. I should actually now call, and we see that now we get a new column called new. Perfect. Now, what if I want to delete this new column? Let's gain some space here. Head, let's show only 3. Now I want to delete this column, and I just type del for delete, then what I want to delete. In the same way that you can access, you can also delete. We only say, look, let's access this column called new, then I want to delete it. If I run it, and now call this data frame again, you see that new is no longer there. Very, very easy, right? There is only one more thing I want to tell you. Let me just delete this example. And the last thing I want to show you as basic operations with data frame is how to perform arithmetic operation. Look that car length here is given in inch, and let's say we want to convert that to centimeter. Let's create a variable called factor and assign 2.54. So that's basically the factor to convert from inch to centimeter. Now I want to create a new column, and let's call it, let's take the same name, car length, but now no longer inch, but centimeter. And this will be, well, we can access this column inch, and we multiply each element by our factor. Then we can print it. Okay, there are too many rows. Again, head, let's show only 5. Perfect. I know that the video is already quite long, but if you are still there, I have one extra exercise. Do you remember when I ran the describe method? And we saw that the brand Toyota Corona appeared 6 times. And now I'm curious to know if they are duplicated rows or not. How can we do that using the methods we already know? Well, let's first access car name. This we already know. We type df. That's the name of our data frame. We use the bracket notation to access the column. Perfect. Now we can test if the elements are equal to Toyota Corona. A bit stupid here because it should be string, right? And what we get is a Panda series where the values are of type Boolean. And every time this condition returns true, we get true. And if it is false, it's going to return false. Alright, this is basically a test. And we can use that to filter our data frame. And then I just type df cars. And what we get is only the rows where Toyota Corona is listed. Okay, are they really duplicated or not? Well, if you look at the car length, they are pretty much different. Oh no, actually those here are same, but the prices are different. Well, they are for sure different elements, so they are not duplicated. All right. In case you're lost about this line here, okay, let me try to break it down. I will just create a new variable, test boolean equals to this test. Then I use this variable here. I can run it again, it's going to return the same thing, but now doing that in 2 steps. All right, the video is quite long, I know, but sorry, it's quite hard to put in one video what is the basic of Pandas DataFrame, but I hope you got the main tools to get started. How to create, how to manipulate, how to view, how to get the basic statistics of your data frame, how to perform arithmetic operation, how to create columns, how to delete columns. Yeah, I think it was too much, but let me know. In the next video, we're gonna talk about a much more efficient way to select data inside our data frame. Alright? Then see you in the next one.